Recording in progress. Hi, students. In this lecture, I am going to discuss center of mass frame. Let us see what is it. It is center of mass frame, or simply calling as C frame. C frame. So its meaning is that we are solving the question from center of mass. For example, earlier we have seen that VCM is equal to M1 V1 bar plus M2 V2 bar and so on by total mass, right? See, from this, what we are saying, total mass of the system into VCM. This is equal to momentum of the system. You can see M1 V1 bar, momentum of first particle, M2 V2 bar, momentum of the second particle, right? Like this, we are taking momentum for each and every particle. Then we have take vector sum of all those things, which is equal to mass of the system into velocity of center of mass. So this is giving us momentum of the system. It is giving us momentum of the system. So now we are saying with respect to center of mass, C frame means solving from center of mass frame. In center of mass frame, velocity of center of mass is 0. I am repeating. In center of mass frame, velocity of center of mass is 0, right? That means VCM 0. VCM 0 means momentum of the system is 0. So I'm writing here symbol, different symbol here, reading as a tilde. I'm writing here, reading as a tilde, TILDE, tilde. This is a symbol we are using for center of mass frame. So this is momentum of the system in ground frame. This is now momentum of the system in center of mass frame. Okay. So this is the first advantage. For system, momentum is 0. Suppose we consider two particle system. Let us take two particle system. Masses M1, M2. Their velocities V1 bar and V2 bar. So we are focusing now two particle system. For this two particle system, VCM will be, so VCM will be, see what we get. VCM is equal to M1 V1 bar plus M2 V2 bar upon total mass M1 plus M2. Let us now focus velocity of each one in center of mass frame, and then we can calculate momentum of each particle in center of mass frame. See, from this point what we can say, in center of mass frame, sum of their momenta must be 0. Sum of their momenta must be 0. Let us calculate now velocity of the first particle in center of mass frame. So it is now V1 tilde, notation is tilde. Its meaning is velocity of the first particle in center of mass frame, means V1 bar minus VC bar. Then see what we get. V1 bar minus In the place of VC bar or VCM bar, write this one M1 V1 bar plus M2 V2 bar upon M1 plus M2. Now see carefully. M1 V1 bar minus M1 V1 bar gets cancelled. M2 V1 bar minus M2 V2 bar. So I can write it as taking M2 outside V1 bar minus V2 bar upon M1 plus M2. Okay. Now multiply this with its mass. Then we get momentum of the first particle in center of mass frame. So P1 tilde that is equal to multiplying with what? With its mass. Then it becomes M1, M2 upon M1 plus M2 into V1 bar minus V2 bar. And here M1, M2 by M1 plus M2, it has one special name, that is reduced mass. Notation is mu. So mu into, this is now V relative, V1 bar minus V2 bar, right? I will write here, mu stands for reduced mass. It is known as reduced mass. So using this frequently, its value M1, M2 upon M1 plus M2. Okay, using that. So now we are knowing that momentum of the system is zero in center of mass frame. That means for second particle also same magnitude, direction opposite. You can see here in this value no change, M1, M2 by M1 plus M2. In the place of V1 bar minus V2 bar, it becomes V2 bar minus V1 bar. Same value, direction opposite. Okay. Same value, direction opposite. That means I can write here P1 tilde is equal to minus P2 tilde. Values are same, directions opposite. Okay. So what I can do here, modulus of P1 tilde is equal to modulus of P2 tilde. That is equal to mu into it is a V relative, modulus of V relative. See carefully, mu into V1 bar minus V2 bar. It is V relative. If you want modulus value, mu into modulus of V relative. Okay. Now, after having this, we can calculate kinetic energy for system in center of mass flux. See carefully. Right. Now we want to calculate kinetic energy of the system in center of mass frame. Right. So kinetic energy of the system in center of mass frame tilde for the system. Okay. Calculating for system. See here, both have same modulus value. Same modulus value. I am writing here P tilde square by 2m1. It is a P square by 2m1 for first one. Next, P tilde square by 2m2. Now simplify this. I am taking 1 by 2 outside. P tilde square. In the place of that, I can write mu square V relative square. Mu square V relative square. Okay. Into 1 by m1 plus 1 by m2. It becomes m1 plus m2 upon m1 m2. Check it once. 1 by m1 plus 1 by m2. Right? And see, this is nothing but 1 by mu, right? 1 by mu. So 1 mu gets cancelled here. Remaining is a half mu V relative square. That is now kinetic energy of the system in center of mass frame. Okay. Suppose you want to calculate now kinetic energy in ground frame, or you can say in any other frame. For example, I am taking a frame A. It can be any frame. Let us take it as A. Kinetic energy in that frame is equal to what I can do is here. Kinetic energy in center of mass frame, that is a half mu V relative square plus, you can see in that frame system moves as a whole, or you can say the system is moving with a velocity that is equal to center of mass velocity. So here I can write half into total mass into VCM square. This is the kinetic energy in that frame. Okay. Suppose I am saying A stands for ground frame. A stands for ground frame. Then this is speed in ground frame. Means speed of center of mass in ground frame. Okay. Plus kinetic energy in center of mass frame. Sum of these two will give us kinetic energy in that frame. And if you observe carefully, if A stands for center of mass frame, if A stands for center of mass frame, then velocity of center of mass in center of mass frame is 0. Means this becomes 0. That means in this expression, you can see this value will be minimum if this is minimum, and its minimum value is 0 because it is a square. So this value cannot become negative. That's why least value is 0. When this becomes 0, its kinetic energy becomes minimum. That means we can say kinetic energy is minimum in center of mass frame. Okay. Kinetic energy is minimum in center of mass frame. That is what we can say. And one more thing here, when we are taking total energy, when we are taking total energy, total energy equal to total energy in center of mass frame plus total energy in that frame. Suppose the frame is A. Okay. Total energy in that frame. Okay. Now see what I can do here. This is equal to total energy in center of mass frame, potential energy in center of mass frame plus kinetic energy in center of mass frame plus, wait here, one small correction. Coming to total energy, so I have to write here total energy in center of mass frame plus kinetic energy in that ground frame. That means, let us rewrite once again. Right, see carefully. Total energy in a frame A, that is equal to, I can write potential energy in that frame plus the kinetic energy in the same frame. Okay. Now this is equal. Coming to potential energy, this is not depending on frame. In any frame, potential energy is same. Okay. So here I can write same thing as potential energy in center of mass frame plus in the place of Ka. Now write here kinetic energy in center of mass frame plus half m VCM square, that is in a frame. Okay. Now this becomes potential energy plus kinetic energy. That is a total energy in center of mass frame plus half m VCM square in that frame. See, mainly confusion comes here, potential energy. For example, take spring potential energy. When you are taking spring potential energy, it is equal to half kx square. K is a constant. Coming to elongation or compression, this is not depending on the frame, right? Whichever frame we consider, either elongation or compression, value will be same. That's why potential energy frame independent. See carefully from this one and from this result, we can say that kinetic energy of the system or total energy of the system is minimum in center of mass frame because in center of mass frame this value 0. Therefore, this is also 0, right? So both are minimum in center of mass frame, right? Let us solve problems to get more clarity. Means where we use the concept of center of mass. So we have discussed these 2 points, right? Momentum of the system is 0. Kinetic energy and total energy of the system is minimum in center of mass frame, right? Right. Let us see problem. Two blocks of masses 3 kg and 6 kg are connected by a horizontal massless spring whose spring constant is 200 Newton per meter. They are placed on a smooth horizontal surface. When spring is in the unstretched state, velocity of 3 kg block is 1 meter per second and that of 6 kg block is 2 meter per second. And directions are opposite. Find the maximum compression or elongation of the spring. Let us see. We can solve this question. One is from ground frame and second from center of mass frame. So first write down given data. There are two blocks, connecting them by massless spring, placing them on smooth surface which is a horizontal. They are given velocities. Suppose this is 3 kg block, this is 6 kg block, and K value given 200 Newton per meter. Its velocity 1 meter per second. Its velocity 2 meter per second. We have to find maximum compression or elongation. Right. Let us see. When you are taking center of mass frame, momentum of the system is always 0 in center of mass frame. Right. Now we can see given velocity is 1 meter per second and 2 meter per second. Right. When they are having maximum, means when spring is having maximum elongation, when spring is having maximum elongation, what will be their velocities? Okay. To get this one, better we can take center of mass frame. Because when we take center of mass frame, the blocks always move opposite to each other. Means direction of their velocities will be always opposite because in C frame, momentum of the system is zero. They must be always opposite, right? And we can say when compression maximum or elongation maximum, compression or elongation. Okay, C for compression, E for elongation. Maximum. In that case, they come to rest. Their velocities, you can say V1, V2, both will be equal to 0 in center of mass frame, not ground frame. Why? Because momentum of the system always 0. This is clear, right? So elongation becomes a maximum or compression becomes a maximum when they come to rest temporarily, right? That's why in center of mass frame, their velocities are 0. This implies, remember, in center of mass frame, their velocities are 0. Its meaning is in ground frame. In ground frame, their velocities are V1 bar is equal to V2 bar, that is equal to VCM. Okay. In ground frame, their velocities are equal to velocity of center of mass. That's why in center of mass frame, their velocities are 0. Okay. I can keep your tilde. Center of mass frame, right? Okay. Now see carefully. If I'm solving the question from center of mass frame, from center of mass frame, since there is no energy loss, I can write initially kinetic energy, that is half mu v relative square. This was the kinetic energy of the system. Initially, spring was unstretched, means no compression, no elongation. So, kinetic energy is nothing but total energy. This is completely converting into spring potential energy because in center of mass frame they come to rest temporarily. So, it is equal to half k x square, or you can say x maximum. Okay. Now simplify this. Half new value m1 m2 by m1 plus m2. 3 into 6 by 3 plus 6, that is 9. Okay. V relative square. 2 is right side, 1 is left side. If this is a positive, that will be negative. That means V relative will be 2 minus 1, that is 3. V relative square, 3 square, that is equal to half k value 200 x square maximum. 3 into 6 by 2. This is 2. 2 gets cancelled. 3 square. Here 2 and 2 gets cancelled. X maximum is equal to 3 by 10, right? 0.3 meter. Or this is 30 centimeter. Okay. Like this, we can solve the question from center of mass. Suppose we are not taking center of mass frame. If we are taking ground frame, then see how we solve. If we solve from ground frame. So first we write momentum equation. I am writing here LCM. Let us take right as a positive. Momentum 6 into 2. Left will be negative. So minus 3 into 1. That is equal to, at the time of maximum compression or elongation, they have same velocity equal to velocity of center of mass. I am writing directly 6 plus 3 into VCM. Okay. So from here we are going to get VCM, right, directly. That value how much? 12 minus 3, 9. 9 by 9, 1. So 1 meter per It is 1. So 1 meter per second, right? Next, write energy equation. Law of conservation of mechanical energy. Initially, kinetic for both half m v square for 6 kg block plus half m v square for 3 kg block. Initially, no potential energy. Finally, both having same speed. So I'm taking 6 plus 3 total mass into VCM square. It is 1 square plus half K x square x maximum. So if you solve from ground frame, writing LCM, finding VCM, next taking law of conservation of mechanical energy. Okay, writing energy equation. So having two equations. So here directly in one single step we can write, okay? Half mu v relative square equal to half k x square, right? Let us take one more problem. And this question is taken from H.C. Verma. A small block of super dense material has a mass of 3 × 10⁻24 kg. It is situated at a height h much smaller than Earth's radius, from where it falls on the Earth's surface. Find its speed when its height has reduced to h by 2 and mass of Earth. So mass of particle is now half of that of Earth. So find its speed. Let us see. One particle, and this is now Earth. And keep one point in mind. Mass of the particle is half of mass of Earth. If Earth mass is m, its mass is m by 2. So when particle falls down, Earth moves upwards. So till now we have seen like dropping small particles, small objects. Okay, that's why we have taken Earth almost at rest only. But here mass is comparable to mass of Earth. So Earth also moves upwards. This point we have to keep in mind. Suppose velocity of particle is v, which we have to calculate. According to means if you solve from C frame, momentum of the system is zero. If this is v, its velocity will be see how much it is. M by 2 into v should be equal to m into it must be v by 2, right? So its velocity must be v by 2 because both must have same momenta. That means magnitude same, directions opposite. So mass m by 2, velocity v. Mass is m, velocity v by 2. So that directions opposite, they will cancel. Now I'm solving the question directly from center of mass frame. Therefore, loss in gravitational potential energy. Initially, separation was h. Now, separation is h by 2. So, loss in potential energy m by 2 g h by 2. Because condition here, height is very small compared to radius of the Earth. Okay. So, taking g value constant. So, mass m by 2 g from h to h by 2. So, m by 2 g h by 2. Loss in gravitational potential energy. This converts into kinetic energy for system, that is a half mu value m by 2 into m1 m2 by m1 plus m2 3m by 2 half mu v relative square. One is v downwards, other one is v by 2 upwards. So v relative 3v by 2 whole square. Half mu v relative square. Okay. Directly one single step. Remaining calculation part. See carefully. M by 2 gets cancelled. Mass m and m gets cancelled. One, two left, right here. Right, we want now here what is left. 2 square, right? 4. 2 and 2 cancel. Remaining is now here. 2 is left here. 2gh, that is equal to 3 square and 1 3 left here. 3v square, right? That implies v equal to root of 2gh upon 3. Okay. See carefully. 2 left, 2gh. Here 3 left, 3 and 3 square. 1 3 left here. 3v square equal 2gh. So v equal to root of 2gh upon 3. Right? Like this, we can use center of mass frame to solve questions in a more simple way. Okay.